The goal of our project was to recognize common user products, like disposables such as cans, water bottle, or other food stuff like pasta packages or coffee capsules. We want to use the state-of-art of computer vision algorithms and low latency response. This to stress the performances of MAX78000. To have more fun, we added some other constraints. Small footprint for the hardware design, for example, low power consumption, inference on board, so the device can operate without any internet connection. And last but not least, we want that our system could be easily extended in order to recognize other objects in the future.
In Kalpa, we normally approach such kind of developments using almost three different approaches. The cloud-based way is preferred when low latency is not a priority and the device is connected to the internet with a wideband connection. In our scenario, we cannot use the cloud-based approach because it requires an internet connection and the latency is too high. On the other hand, when the device must operate without an internet connection, we normally use a CPU or a GPU-based device. The edge processor is normally a Linux embedded device. In this case, the price to pay is a higher power consumption and the longer boot time. But we have in return a very low latency response because of the CPU power that the device has under the hood. The high power consumption of a CPU-based device put this kind of approach out of the possible solution to our project. The third approach that we could use is a low power device, such a microcontroller. Normally, the performances of a microcontroller is not enough to deal with any machine learning application. The MAX78000 is equipped with a neural network convolutionary coprocessor. That is the key to assure an acceptable latency time with the lowest power consumption. The MAX78000 specification seem quite near to what we need for our project. We need to test it in a real-life scenario. The MAX78000 is an artificial intelligence microcontroller with a low-power convolutional neural network accelerator. It uses a low clock speed ARM M4F core. It works well with the object or face detection applications, but also with audio and sensor data processing. In our project, we have used the Cube Camera Evaluation Kit. It is a good tool for development because it has a quality camera and a display on board, together with buttons and a USB connection.
The development flow of this kind of project on this platform could be resumed in three phases. A PyTorch or a TensorFlow model is created with a series of well-defined subclasses in order to reflect hardware capabilities. This model is trained using floating point weights and training data. Weights can be quantized during the training phase or even after that. The result can be evaluated to reach the target in terms of performance, such as accuracy, recall, precision. Then, synthesizer tool accepts this model as input and generate a C code, which can be compiled and executed on MAX78000. At this point, firmware engineer can integrate this code with application logic, for example, to print the result on screen. To achieve target of our project, we used a convolutional neural network with 17 layers, and 3 of that is just used as a residual layer to speed up the training phases and increase the performances. In order to cope with problem of vanish gradient and also overfitting, was necessary to use batch normalization.